Alright, so some more examples for solving using the quadratic formula. So in this case, A, we have negative 2 times y squared equals 3y minus 4. B, x squared plus 11x equals negative 18. And it's S. For number 1, what do the solutions represent? And 2, what about when the result is the square root of a negative number? Okay, so I should probably get rid of number 2 first. That would make sense later on in case we see it. So square root of negative 9, for example. What happens when we take the square root of negative 9? Well, let's try with our calculator. If I go second, x squared gives me the option of square root. So second and the x squared on the left side, somewhere in the middle of your calculator. Putting negative, the negative at the very bottom next to your enter button, otherwise you'll give you an error. And then the 9. Close your parentheses. And what does our calculator tell us? Error, non-real result, or non-real answer. So we can't do it, in other words. If it's a square root of a negative number, we can't do it, so it's a non-real result. We typically say non-real result. If you've already seen imaginary values, then you can call it an imaginary result. But otherwise, we're just going to state non-real result for now. So, in this case, let's write our equation that we're going to use, our general quadratic equation, y equals ax squared plus bx plus c, and I've highlighted the colors, or changed the colors, to be able to tell the difference between a, b, and c. And our quadratic formula. So we have x equals negative v plus or minus the square root of v squared minus 4ac, and then all of it divided by 2 times a. So our expression in this case, first expression for a, it's negative. And then notice that it's negative 2y, but I've converted it to 2x. Otherwise you're going to confuse yourself, maybe, hopefully not, with the y that we have up above. So you can generally use any variable that you choose. We could have changed that to an h, for instance, or g. So negative 2h squared equals plus 3h, etc. But in this case, I decided to use the x. That way I can keep it constant for this video at least. So negative 2x squared equals positive 3x minus 4. Notice I don't need the positive on that 3, but just so you can see that it's there. It's a positive 3. Okay, so now we gotta get rid of everything and set it equal to 0. So we gotta move the negative 2x squared. So let's move the 2x squared to the other side. Since it's a negative, we move it as a positive. Since we are moving it to the other side. There we go. And I can combine the 3x with the positive 2x squared. We have oranges and grapefruits as an example. They're similar, they look similar, but you can taste the difference, right? And in many cases, you can actually see the difference. So even though they look alike, they're not the same term, so we can't combine them. So all we can do is write them next to each other. Notice that I did not write the positive on the 2x squared, but it's still positive because there is no negative sign. So we have 0 equals 2x squared plus 3x minus 4. And notice I wrote them in order so that we can actually see it a little bit easier. Which one's A, which one's B, and which one's C. You can define that by which one has an x squared, which one has an x, and which one does not have an x. So we're going to fill in the blanks from our quadratic formula with a ramekin or square root on it. But let's first be aware that we're looking for a, b, and c from what we previously simplified. So the a value, we can tell that it's a 2, b value is 3, and c value is 4. Okay. I just realized it should have been a negative 4. But let's continue filling this in. We'll fix it in a minute. So we have a values of 2 filled in, and b values of 3 is filled in now. And there we go. That's correct. So technically we got the correct value inside our radicand, but wrong value for the c over there on the left side. So be aware of that. I'll come back and change it later on. So x equals then negative 3 plus or minus the square root. In this case, 3 squared gave us 9. So simplifying one step at a time, I highly recommend this, or maybe a couple sometimes if it's possible. In this case, we did 3 simplifications. The 3 squared gave us 9, and then we went negative 4 times 2 gave us negative 8. And we just brought down the negative 4 for multiplication in a minute. And down at the bottom, we have 2 times 2 gives us 4. Alright, now let's simplify in the next step. It's 8 times negative 4. 8 times 4 would be 32. Negative times a negative, a positive. And we still have the square root, right? So that's the only thing we simplify. The negative 8 times the negative 4 to give us positive 32. So up next, 9 plus 32 gives us 41. And we're taking the square root of it now. I highly recommend you, well, maybe use a calculator. Maybe easier in this case, rather than guessing and checking. So we go second, x squared will give us the square root. The x squared button will give us the square root button. So second x squared will give us the square root, and type in 41. Hit enter, and now we get our answer of 6.4 roughly. So now that we got our answer, notice our approximate, because now from now on we basically have approximate answer since we rounded. So negative 3 plus or minus 6.4 divided by 4. And now we can split it up into 2 different answers because it's a plus or minus, right? So this one's a positive, and the next one has a negative in between that 3 and the 6.4. So the first one, we have negative 3 plus 6.4 divided by 4. So negative 3 plus 6.4 will give us 3.4. So 3.4 divided by 4, this will be a calculator, right? Should give you 0.85. Try it out on your calculator, make sure I got it right. So there is our first answer. And let's go for the second answer. Negative 3 minus 6.4. That will give us negative 9.4. So 9.4 divided by 4 should give us 2.35. Whoops, I see I missed my sign there. I'll come back and fix it in a minute. So I have 2 errors to fix. So that should have been a negative 2.35. Be aware of that. Okay, going for the next one then. I'll try the next example. So in this case, we have negative 18 equals 1x squared plus 11x. And likewise, I want to get rid of the 18 to the other side. Hence the reason why I put the 18 on the left side rather than the right side. Because I want to have it as 0 equals. Just to make it look like our initial formula. But otherwise, having it on the right should technically be still okay. You should end up with the same. So I'll get rid of the 18 to the other side, plus 18. And so therefore, 18 does not have an x, so I just add on to it. So we have 0 equals 1x squared plus 11x plus 18. If you have it in the form of 1x squared plus 11x plus 18 equals 0, that's totally fine. It's the exact same, except just on the opposite side. Notice your signs should not be any different than what mine are. So we're going to fill in what the a, b, and c values. And we can tell that a is 1, b is 11, and c is 18. So now for our quadratic equation, or quadratic formula, I should say. There it is, our quadratic formula, filling in the a, b's, and c values. So a values, 1, there we go. There's our 1's locations for a. And b values, there we go. There are our b values for the 11, in other words. And just the c value of 18 there. And let's simplify. I really don't need the negative on the 11. Let's see, 11 squared, that's where your calculator could come in really handy. So 11 times 11 should give you 121. Double check with your calculator. If I go 4 times 1 is just 4, right? 4 times 18 should give you 72. Highly recommend you check with your calculator. 4 times 18 should give you 72. And then a negative times a positive gives you negative 72. 2 times 1 at the very bottom is still 2. So simplifying, 121 minus 72 should give us 49. Once again, I highly recommend you double check to make sure I got the right answer. And taking the square root of 49, sounds like 7, right? So negative 11 plus or minus 7 divided by 2. So technically this would be our exact value answer if we don't want to split it up. Then we would circle it as our answer. But let's try splitting them up, see if we can get an exact value on each one. So splitting it up into 2 different equations because one's positive, one's negative. So x equals negative 11 plus 7 divided by 2, and the other one, x equals negative 11 minus 7 divided by 2. Hence the reason why we have a plus or minus previously. So let's simplify the one on the left first. Negative 4 divided by 2 in this case. And that'll give us negative 2, agreed. So there's the first answer, going for the right side. Negative 11 minus 7 divided by 2, negative 19, 18, right? Pretty close. So negative 18 divided by 2, half of 18, 9. So negative 9. So our answers, x equals negative 2 and x equals negative 9 are our final answers. Now that we have both of our answers, let me go back real quick and fix the minor errors on there. I'm missing a negative on this one, on the left side expression. So negative 9.4 divided by 0.4. And we should end up with a negative answer there. Negative 2.35. Whoop. There we go. Negative 2.35. And I might as well make my circle, or square in this case, a little bit bigger. There we go. And just a quick check. That way we can visually see a little bit better what we just did, because it's kind of hard to see. And now I should be able to state or define number 1 there. What do the solutions represent? We already stated that on number 2, when we get a negative answer in the radicand, we would state another result. So for instance, if I either got a square root of 41 or a square root of negative 41, then I wouldn't be able to continue any further. I would just say not real result, and that's where I would stop. Or square root of 49. On the other example, I would say not real result, and I would stop if it was a negative. So let's try this out though. And let's go to y equals, and let's clear this out. And in this case, I'm going to make it as 2 separate examples. Negative 2, I need to call it x because my calculator only knows the x value, 2x squared. There we go. That's our first equation. Hit enter or push down to go to the next one, and we're going to call that one 3y, or 3x, right? Minus 4, since your calculator only knows the x value. So let me cover over here, since we're doing the one on the left first. We want to go to zoom and do a zoom standard, option number 6. And let's see if we can see the intersection points. We can sort of see the intersection points, agreed? And in this case, let's see, I'll go to zoom and do a zoom out, option number 3, so that it makes it easier and to see. And notice that we have to hit enter, otherwise it won't zoom out. There we go. And I'll do a zoom box to make it a little bit easier to see. So zoom, option number 1. And let me move my cursor up. There we go. There's my cursor. I'll hit enter. Push down and hold down until I see I'm far enough down. And then push to the right and hold the right button. There we go. Too far. Roughly there would be good. So there we go. Now we can see the intersection points of both of those equations. Hence, the solution of x equals 0.85. So if I hit trace, the trace button up at the top right allows me to enter any x value. I'm looking for 0.85. Hit enter. And it tells me roughly the location, which I can visually see it's roughly where they both intersect. So yes, this is roughly the answer. It's an approximate answer, right? Be aware of that. Or I can also go ahead and enter negative 2.35, and it should go to the other intersection point. Yeah, it does. There we go. Let me move my cursor. There we go. Because we can actually have the calculator do a little work for us, meaning double check. We can do a second, and right next to the graph button, you'll see a trace button once again. By pushing the second and the trace button, it gives you the option of calculate. We want to calculate the intersect, option number 5. Go down to number 5 and hit enter, or push 5, which automatically goes into the option of 5. Intersect, and we want to find the intersect. It asks us, is this the first curve you want to use? Up at the top I see a y1. I'll say yes by hitting enter, and it switches automatically for me. It asks me, is this the second curve? Up at the top I see y2, so I'll say yes. I'll hit enter once again, and now it gives me a guess. Well, I don't want to guess, I want exact, so I hit enter one more time, and now it goes to my intersection location. There it is, which is x equals negative 2.350781. And it's roughly close to what we approximated earlier, negative 2.35. Let's go for the next one. Second trace will give us the option of calculate. And we want to go option number 5, push the number 5 button. and it automatically goes into the option. I want to go closer to the other intersection point, otherwise it gives me the same location. So roughly there. And I'll say yes, that's my first curve now by hitting enter. It jumps to equation number 2. I'll hit enter again. And it gives me a guess. So I don't want a guess, I want an exact value. So I'll hit enter one more time. And now it should give me my actual intersection of x equals 0.85078106, or roughly what we got earlier, 0.85 when we rounded it. So it looks like we got it correct. Let's double check the other one real quick. That one should be a little bit easier, I hope. Let's clear this out. So go to your y equals and then clear it out. On y1, we're going to plug in x. Whoops, sorry, wrong one. Go ahead and go back to y1. There we go. On y1, we're going to plug in x squared plus 11x. And go down or hit enter and put negative 18. Be aware, if you get an error, that's because you put a subtraction sign. It has to be a negative sign before for the 18. Agreed? The negative sign at the very bottom next to your enter button. So I'll hit a zoom and do a zoom standard. Option number 6. Let's see if we can see where they intersect. Probably not, because I'm looking at negative 18. So I'll go to zoom and I'll go zoom out. Option number 3. Push the button 3 and hit enter, otherwise it won't zoom out. There we go. And now I should be able to see where they intersect. Yeah, I can. And this is a quick check. I'll hit trace once again. Trace, top right button. Trace. Negative 2 is our x value that we got. And we can see that it sort of does look like it's the intersection point. And I'll plug in negative 9. And realize that it goes to the other intersection point. Yeah, it does work. Or have the calculator do a little more work for me by, I'll move it away, that way we can actually see it. I moved it away, then go to second, trace, to do the calculation from the calculator instead, and do option number 5, push the 5 button, and hit enter once, twice, and gives you a guess. You want to hit enter again, 3 times. And now it actually gives you the answer. Negative 9 is your x value, and the y value is negative 18, but that's because we care about the x value answer. We can repeat that once again, second trace. We want to do option number 5. You can go down to number 5 or push the 5 button, automatically does it. But I want to be closer to the other intersection. Roughly there, let's say. Or maybe I should go up higher. There we go. That way I can visually see I'm not close to the other side, or the other intersection point. I'll hit enter to say yes, that's my first curve. Yes, that's my second curve since it automatically jumped. Don't want to guess, hit enter one more time. And there's the exact value of x is negative 2, which is exactly what we got. So there it is. We checked twice in the 2 different formats using a calculator as well. You're welcome to go back and check by plugging in the values in the x. You should get them to be equal as well. So manually plugging in the x values or y values, depending on which one you use, and actually noticing that they should be equal. So this completes our example.